I'm Chris Jacobs, and I teach at Marietta College. Today we're going to talk about the first part of the math section on the FE exam. We're going to go through some of the problems that you might be likely to see on the FE exam in the math section. So the first question we have over here is we have a conic section represented by this formula. So as you're going through and you're reading the questions on the exam, you always want to look for little key words that you can use to help you solve the problem. So in this case, the key word is conic section. So then we're going to go to the NCEES handbook and we look for conic section. And you can see this right here is the general form as it is listed in the NCEES handbook. So the first thing we need to do is take this formula and expand it out so it comes closer to matching that. Now once I have it expanded out, you will see that this format does not match the standard form. In order to use the standard form, you have to put the expanded equation into the standard form, which is what I did down here. So I have the x squared term, the xy squared, and so on and so on. It exactly matches the standard form. Now according to the NCEES handbook, in order to determine the conic section, you want to compare b squared minus 4ac. So then you go back up to your equation in the standard form, and I have 0 minus 0. Okay, and then from the NCEES handbook, we can determine that 0 is a parabola. So obviously the answer would be A. So here we have an equation given, and we want to find the roots of the cubic equation. So the first thing we can do is we can expand it and try and figure out how we're going to solve a cubic equation and do the time. However, as engineers, these exams are much about using engineering judgment as engineering knowledge. Look at all of these answers here. All four answers have the number 3, either plus 3 or minus 3. So they're practically telling you that 3 is a root. So now you go back to the original equation here. Obviously you have an x cubed with 2 minuses in here. Given the fact by inspection 3 must be a root. So now when you put 3 in there, you can figure out that the answer is D. And obviously there's only one of the multiple choice answers that has a positive 3. So pretty much once you know that 3 is a root, you can look at D. So again, don't take your first option to say, let me flip through the book and start using my calculator and start doing it by hand. Always look at the problem, look at the answers, and see if you can infer something from that. Because the time you save doing this will allow you to use that extra time later to solve a problem that may take a little bit more time to solve. So here we have two vectors, f1 and f2. Okay, so the dot product of two vectors is shown here. It's got a cosine in it, cosine of an angle. So when you see the word angle between two vectors, you're going to use the dot product. So when you put all this in here, you've got your two vectors, and then you've got the square root of the two parts of the vector here, and you come up with 0.905. So a lot of times, people are very excited. Okay, I entered the data in my calculator. I got the answer 0.905. Let me go up. Okay, there it is. The answer is A. Be very careful. The question asks for the angle between the two vectors. This is the cosine. So when you take the arc cosine, the correct answer is 25.2 degrees, which is C. So this is the kind of thing you will see on the exam where they will put some breadcrumbs in here. Okay, if you did the calculator work, you're going to get an answer, but it's not the correct answer. So be very careful that you don't just enter numbers in your calculator, come up with an answer, and then, oh, by the way, that answer is there. Make sure you're actually answering the question. So here we have a question. The area of the parallelogram by two vectors. Again, f1 and f2. Now the area of the parallelogram is the resultant of A cross B. So now we're looking at a cross product. So when you have a cross product of two vectors, it becomes a 3 by 3 determinant. So across the top, you'll put your unit vector I, J, and K. And it's very important, and this is not specifically written in the NCEES handbook. This second column always has a negative sign above it. And then the next row is going to be your first vector, and then the bottom row is going to be your second vector. So the way you expand it out into this format over here, if you're going to do I first, so you bring the I out in front, and then you block off the column and the row, so then you end up with 4, 6, and 10, 7. And then, of course, minus j the same way, and minus k. And you will remember that the solution to a 2 by 2 determinant is a1, b2 minus b2, a1. Now this is specifically written in the NCES handbook, so you will not have to remember that. That is there. But you do have to remember to expand I, minus j, and k. So when you cross everything out, you end up with this vector here, and the area is the resultant, which is the square root of each of those values, and you get 47.9. Now, one thing you will see on the exam, and you noticed it in the video, if you watch the video in the introduction to the exam, the problem will usually say most nearly. So it will be rounded up to a certain number. Sometimes they'll tell you they want it to the nearest thousands. So read the problem carefully. Okay, here we're asking for the summation of this series. Okay, now this is an example of a fill-in-the-blank type problem. I did not list any multiple choice answers. So when you're looking at this problem, the first thing you're going to want to see is the word series. That tells you, okay, now I'm looking at series. I can search in the NCES handbook for series. So we have several series. We have geometric and arithmetic. So for geometric, you divide each number by the preceding number. If the quotient is the same, then it's geometric. In this case, it is. I don't care which number you pick. You can pick, for n minus 1, just pick 2 and 3 or some number. And you'll find out that it's geometric. And then the formula right out of the book comes there. You put in your 1 and your 7 to the fourth terms, and you're going to end up with 1200. So on the fill-in-the-blank problems, now in this case, that's an exact number. By and large, for the fill-in-the-blank problems, NCES, again, is not seeing how accurate you can be with your calculator. They're going to give you a range of accepted values. So, because sometimes people will use the pi button on their calculator. Some people will use 3.14. Obviously, you're going to get a slightly different numerical answer. They're not trying to see how accurate. They're going to give you a range of accepted answers. Okay, we have a pizza restaurant. 5 toppings. How many, given one minimum, how many combinations are there? All right, so in combinations, the order is irrelevant. Some pizza restaurants will put the pepperoni under the cheese. Some pizza restaurants will put it on top of the cheese. It really doesn't make a difference which one you put on first. Okay, so the formula for combinations is given here. All right, so we need to be paying attention though. If we say, okay, we have 1 topping minimum, how many combinations are possible out of 5? Okay, we have n is 5, we put in r is 1. That is incorrect. What if I want 2 toppings or 3 toppings? So in this case, the total number of combinations is the sum of all of these. Because it says given a 1 topping minimum, how many combinations are possible? I may want 3 toppings. A friend of mine might want 1 topping. So the total number of combinations as possible is the summation of all of these. So I've got here, this is 1 topping, 2 toppings, 3 toppings, 4 toppings, and 5 toppings. And when you do all that, you have 31 different combinations of pizza. So a fairly simple problem, but just make sure you know you have to take the summation of that. If you just take and you put in 5 and 1 and you expect an answer, you're missing out on a lot of opportunities there. So again, this is what you want to be careful of. Baseball team has 11 players, 9 players in the batting order. How many different batting orders are there? Okay, now this is an example of a permutation, okay, because order matters. If I'm the catcher, in one batting order, maybe I'm cleanup. I'm batting the 4th position. In another batting order, I'm batting the 7th position, so as a catcher. Now the order matters. So you can't just do the combination one. You have to do this. You'll notice the formula is different. That's how you can get it through. And you get almost 20 million different batting orders. That's with 11 players on the team. I am not aware of any baseball teams that have 11 players. So you can imagine if you had 30 players, this number would be very, very high. Now obviously there's more to it than just saying I've got 20,000 combinations here, 20 million combinations. You're going to want to go through and use, okay, this is my best player, it's the ninth inning, so this just gives you a number, not what batting order you should choose. Okay, here we've got a bowl that has several different color balls in it. So we want to know what the probability is of getting first red and then yellow without replacement. So obviously if you can see into the bowl, then it's easy. I'm going to pick a red one and a yellow one. So they're assuming blind test. So this is a joint probability problem, which states what's the probability of A given B, or B given A. So in this case over here, we've got the probability of A times the probability of B given that A has occurred, which is what we said. We want to draw a red ball. Given that we drew a red ball, what is the probability of drawing a yellow ball? So obviously that tells you how many different color balls in here. So initially, the probability of getting a red ball is 2 over 20. 20 balls total, 2 red, pretty straightforward. The probability is 0.1. Now that we've drawn a red, the probability of drawing a yellow, there are 4 yellow balls. 19 balls remain. Not 20, because we drew one out. We only have 19 left. So the probability of getting a yellow ball after having drawn a red ball is 0.2, or a yellow ball. The probability of drawing a yellow ball given 19 balls left is 0.21. So the total probability is 0.1 times 0.21, which is 0.021. Because that's the probability of first getting a red and then getting a yellow is 0.21, 0.21. Five students, 5% of students have red hair. If 7 students are selected at random, what is the probability that exactly 3 will have red hair? So if you just look at that problem and think about it, we're saying 5% of students have red hair. That is a low number. You're going to draw 7 students and have exactly 3. That's going to be a very low number. So this is going to be a binomial distribution problem. And in binomial distribution, it's black and white. Either you succeed or you don't succeed. We're not asking how much of what percentage did we succeed by. Either you do or you don't. So this is the formula we use. It's X successes in n trials. P is the probability of success. Q is the probability of failure. So in this particular case, obviously, once we know what all these values are going to be here, the probability of success was given as 5%. The probability of failure is 95%, 1 minus the probability of success. And when you do that, the probability is 0.00356. Again, that's a very low number. Given only 5% have red hair, we're picking 7 students and we want to have 3 have red hair. That's a very low number. Normal distribution is another type of statistical function. Again, the problem specifically states normal distribution with a mean of 16 and a standard deviation of 4. What is the probability of getting a number greater than 4? Okay, so if you just think about that in your mind first, the mean is 16. 4 is way down over here on this side if the mean is 16. So you're saying, well, we're going to be, that's going to be pretty high. So the formula for normal distribution is given here. Okay, this is the number we're looking for. This is the mean, and this is the standard deviation. So I get -3. Okay, that doesn't really tell me anything. So in the NCEES handbook, there's a table that has the normal distribution on it. And I cut it down, so I mean the table's a full page. I just cut it so we could look at what we're looking at over here. Remember, we had a -3. Okay, so you look over here. Well, I don't see a -3 in this X table. It goes from 0 all the way to 3. So what am I going to do? Well, if you look at these graphs up here, Okay, we said that it had a mean of 16. So, and we're looking for numbers greater than 4. So if you flip this around the other way here and you put this white spot over here, this is representative of what you're looking for, this area in here. So in this case over here, f of minus x is equal to f of x. So now you read down and you get 0.9987. And again, if you thought about the problem, and what the problem statement says, that we have a mean of 16 and we're looking for the probability of getting a number greater than 4, this answer makes plenty of sense. If you were to say, okay, well, maybe I'll use this one, that answer does not make sense. Here we have a function. We want to know what the maximum of this function is. So before we can even do that, we need to know what the definition of a maximum is. Well, again, it says when f prime is equal to 0 and f double prime is less than 0, that means we have a maximum. So the first thing we're going to do is take the two derivatives. Okay, we need to satisfy f prime equal to 0. So we set this equation equal to 0. We get plus or minus 1. So obviously, which one of those two is going to be less than 0 to satisfy it? We know the answer is going to be that. So x is equal to 1. We go back and we solve it, and then we get the solution as 2. So again, just be careful you don't say, okay, x is equal to 1. Again, NCEES could say, okay, I got a 1. Let me put a 1 up there. That's not what you want. You want to solve the equation for the value of x equal to 1, not just putting x equals 1 in as a solution. Okay, here we have a function. Z is equal to 3x squared and so on and so forth. We're looking for the partial derivative with respect to x. So the first thing you need to remember is what exactly is a partial derivative. So in a partial derivative, anything that's not the variable to be differentiated is treated as a constant. So the partial derivative of this function is 6x plus y. Because this is a 6y squared, we don't care about it. That becomes a constant. This becomes a constant. This becomes a constant. So you're only going to differentiate the 3x squared and the xy, and you're going to get 6x plus y. So again, don't just try and differentiate the whole thing. When it says partial, you need to know you're only doing the variable to be differentiated, and the other ones are treated as a constant. So we're asking to take the limit of this 1 minus cosine x over x squared as x approaches 0. Well, if you put 0 in here, basically it's indeterminate. The function is just going to blow up and you're going to get a number that's indeterminate. So you need to use L'Hopital's rule, which states that if the limit of these two functions, or function 1 over function 2, is indeterminate, then the limit is also equal to the limit of the first derivative of each of the functions, which is also equal to the limit of the second derivative of each of the functions. And technically you can go on forever. At some point it becomes futile, but you can do it. So in this case over here, we take the first derivative. Now we have sine x over 2x. Well, this still goes to 0 over here because now we're still dividing by 0. Take the second derivative again. Now we have the cosine of x over 2, which comes down to 1 over 2, or 1/2. Well, thank you for watching the video. This is the first part of the math review. I will have another part coming up. So thank you for watching the video.